Hello everyone, I hope that I'm live right now. If you guys are able to listen to me properly as well as there's no issues with the audio or the video, please let me know guys. Hello everyone, good evening, good evening. I hope that I'm live right now guys. If you guys are able to listen to me properly as well as there's no issues with the audio or the video, please let me know guys. Good evening everyone, good evening. Good evening everyone. Awesome. Awesome. So yesterday I had given you guys some assignment, right? Could you guys let me know? Yesterday I had given you guys some assignment. Could you guys let me know what was the assignment of? Good evening, everyone. Could you guys let me know what was the assignment for yesterday's class, guys? To rewatch the video, and we'll be asking a question today. So for today is that how many of you guys didn't revise the video? How many of you guys didn't revise the video, guys? How many of you guys didn't revise the video? Because today I will be putting a question in the attendance form. Those guys who are not able to answer the question right will not be getting the attendance for today. Okay, I'm being very clear about it, guys. Today, those guys will not be like answering the question right, will not be getting the attendance for today's class. Okay. Secondly, those students who are putting up the answer in the live chat, those students also will not be getting the attendance for today's class. Okay, be a little bit selfish, guys. If you are putting up the answer in the live chat, then people who are not attending the sessions will also be able to get the same certificate as you, and the value of your certificate will be less. Understand this, guys. If you know the answer and you're putting it up in the live chat, then in that particular case, people who don't know the answer, who have not attended the session, who have no knowledge, will also be able to get the certificate. Now the person with the knowledge, with the skills, who has attended the class, and the person who is not attending the class, who is not listening to us, who is not doing anything, is also able to get the certificates. Then there is no value of the certificate itself. If you are putting up on your resume, it has no value to it. Okay, nobody cares about that certificate because it is given to everybody. Okay, so please remember this, guys. If you are putting up the answer of the question in the live chat, it is your problem at the end of the day. You will be facing the consequences, and we will be noting down the names, and these people will not be able to get their certificates as well. So this we are doing it just to make sure that people who are actually attending the classes, people who are actually trying to learn, are able to get the certificates as well. Okay, are you guys able to understand this? Please let me know, guys. Are you guys able to understand this? Please let me know. Awesome, guys. Awesome. Okay, so we'll continue from right over where we have left yesterday. So can you guys let me know what have we again, do not let me know. I already remember that, and that question I shouldn't be asking up till now. Okay, no issues in that. So we'll be continuing from the point where we left yesterday itself. Today as well, there will be a bit of theory that will be there. In the last 2 days of the bootcamp, we'll be doing the practicals related to deep learning. That is what my plan is, because before starting, I want to make some of the topics to be a bit more clear for your end as well. Maybe we will be extending the class by one more day. Okay, so instead of having it for just 7 days, we'll be having it for 8 days. Will that be fine with you guys? Please let me know. Instead of having the class for just 7 days, I might be taking it up for 8 days. Will that be fine with you guys? Please let me know, guys. Because I want to make sure that everything that I'm teaching, you guys are able to understand everything properly. Okay, that is what my aim is. Without that, then there is no like benefit of having a class itself. Okay, at the end of the day, our priority is to make sure that you guys are able to understand everything properly. Okay, so let's start off with our today's class, guys. Yesterday we have covered a little bit about our. Okay, so this is completed, I guess. Great. So let me just open up Paint. And let us start with our today's class, guys. So yesterday we learned about the Perceptron model, right? Yesterday we learned about the Perceptron model. Please let me know, guys. Great. So if you guys remember the Perceptron model, we had divided it into two halves. The sigma on the left hand side and then the activation function on the right hand side. And then you had your inputs, okay, the x1, the x2, and then you are having the input as well, c, and then you are having the output y is equals to g of ax1 plus bx2 plus c, okay, where a and b are written right over here. Are you guys able to understand this? Please let me know, guys. And this we refer to as an artificial neuron or a perceptron. Okay, now this is what your core of your brain is. Okay, like I said, the researchers tried to recreate a mathematical formula for creating a neuron itself, and this is what they end up as. Now the neuron has been created, but does your mind has a single neuron inside of it? Does your mind has just one single neuron inside of it, guys? No, right? It has millions and billions of neurons that are present inside your brain at any particular point of time. The same thing we need to understand it right now when it comes to your neural networks. Okay, and the first particular step, okay, have been covered. The first particular step of deep learning is basically your ANN. Okay, is your artificial neuron itself, your perceptron. The next particular step is to link these neurons together. Okay, is to link these neurons together. So I'll just select all of this and make it a bit smaller. Let's make this a bit smaller, guys. And let us now think about your neural networks. Now what our aim is to link these together to do some like complex mathematical equations. Okay, right now it's simple. Okay, ax1 plus bx2 plus c blah 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 blah, blah done. Okay, what about if I want to make something much more complex? Okay, so for that, let's assume that you are having your neurons. So these are your individual neurons itself. We'll be arranging them in a single line. We're going to arrange them in a single line. Each line of neuron is referred to as a layer, L-A-Y-E-R. This is called as a layer of neurons. Okay, you have some inputs. Let's assume that you are having two inputs that are there, x1 and x2. There are two inputs that are associated with each one of them. All the neurons in this particular layer have the same activation function. All the neurons in this particular layer have the same activation function. But the A, B, and C for each of these neurons is different. The ABC, okay, A, comma, B, comma, C for this neuron is different. For A, comma, B, comma, C of this neuron is different, and so on and so forth. Are you guys able to understand this? Please let me know, guys. The ABC for each of these neurons is totally different. Are you guys able to understand this? Please let me know. You remember the ABCs, right? AX1 plus BX2 plus C. That is totally different, but the activation function is the same itself. Now this X1 will get allotted. Okay, we will be connecting this X1. let us connect this with a separate color to each of these neurons. Okay, so this is connected to the first neuron, this is connected to the second neuron, this is connected to the third neuron. Okay, so on and so forth. Give me a second, guys. I'm just drawing all the connections right over here. It will take me a second. The first X1, that is our input, is connected to, is an input to all these neurons itself in this particular layer. Similar to that, our second neuron will also be connected to each of these neurons. Okay, so our second input will also be connected to each of these neurons, guys, just like this. Give me a second so that I'm able to draw it properly for you guys. Are you guys able to understand this? Please do let me know, guys. So each of these neurons in this particular layer, it's connected to each of the inputs that you have. Now these number of inputs can be millions as well. Okay, it's not compulsory to have just 2 inputs. Okay, there can be 3, there can be 4, there can be 6. Just that the equation will be changing. Instead of having the equation as a linear equation in 2 variables, it will be a linear equation in 6 variables, it will be a linear equation in 10 variables. So that is how it will be there. Now all these neurons, okay, there will be a secondary neuron that we'll be having. Okay, there will be a secondary neuron that will be having right over here. This is called as the output neuron. This is the input layer. This is the dense layer. And then you are having your output layer right over here, output layer. Now all these neurons that are there, their outputs, their equations, whatever the outputs are there, that will be connected to the output neuron. So this will be something like this. Okay, each of them will be connected. Their output will be the input for this output layer. Okay, are you guys able to understand this? So this particular neuron, okay, yeah, dense or hidden layer, you can call this as dense or hidden layer as well. You can call this as hidden layer. Dense or hidden layer, both of them are the same names that you can utilize right over here. Now this will provide an output y hat of, so y1, y2, y3, y4, y5. Okay, so these are all the outputs that are coming from our dense or hidden layer, and that outputs will then become the inputs for our new output neuron. Okay, so this output neuron has 1, 2, 3, 4, 5 inputs. So this will generate a linear equation in 5 variables. Okay, it will be a y1 plus b y2 plus c y3 plus d y4 plus e y5 plus f. Okay, that will be the equation, and the activation function right over here need not. So for example, if this is the a1 activation function in all these neurons in the hidden layer or the dense or the dense layer, okay, it can be a2. Okay, it need not be, the activation function for the output layer need not be the same. Okay, the activation function for the output layer need not be the same. As we are able to see how complicated the mathematics got in just one layer. Okay, how complicated the mathematics went in just one layer, guys. Are you guys able to see this? Please let me know. Are you guys able to see this? Please do let me know, guys. Now just imagine, okay, just imagine this, that the number of neurons in this particular layer is more than 180 to 1024. Okay, more than 180 to 1024 in just one layer, and then you are having a densely connected layer. So this is called as a neural network. Okay, this is called as a neural network, guys. We call this as a neural because it's a network of neurons itself, right? Now think about this in such a way that what if you are having some like 15-16 inputs, okay, maybe like 100 inputs that are there. So 100 inputs that are there connected to neurons. Okay, there are like, just like we have drawn one layer, we are drawing like maybe 5 or 6 layers itself. Let's assume there are a lot of layers, and then there is the output right over here. every single input is connected to every single neuron right over here. Every single output from this neuron is connected to every single neuron in the next layer, and similar to that right over here as well, the connections are there, and then it is getting connected to the output layer, and then you are having the output, finalized output right over here. So how complicated the entire network looks like, right? How complicated the entire network looks like. And in each of these layers, there will be 2 to the power n. Okay, there will be 2 to the power n neurons in each of these layers. Okay, 2 to the power n neurons. Why 2 to the power n? I will be explaining that in a second or two. But just think, each of these layers have 512 neurons, 1024 neurons, maybe 256 neurons, and so on and so forth. Okay, so on and so forth. So how complicated this mathematics will be. Now nobody goes to this particular extent. Okay, we just learn about the basic perceptron, we just learn about a basic like ideology of how the network works, and then we start directly go into like perception. We don't learn about all these kinds of like mathematics. Nobody does. Okay, even researchers don't do that. Yes, all these will be referred to as your hidden layers. Okay, all this will be referred to as your hidden layers itself. Yes, Manisha, A2 can be a non-linear activation function if A1 is the linear. Absolutely, that can be the case. Okay. Are you guys? Each neuron has a different activation function, right? Georgia, no. Usually, the neurons in the hidden layer usually have the same activation function. Okay, usually, for example, all the neurons in this particular layer will have the same activation function. All the neurons in this particular layer will have the same activation function. All the neurons in this particular layer will have the same activation function. But for example, this activation function is a linear activation function. Let's say sigmoid, then this can be ReLU, this can be like step. That can be different, but in each of these layers, the activation function will still remain the same. The activation function will still remain the same. Yes, so 3 activation functions. You can have them as all the 3 activation functions can also be the same. Okay, can also be same. You don't have to worry about it. Is there a limit to the layers? No, there is no limit. There are layers that are having like 1 lakh layers as well. So there is no limit in how many hidden layers you can put. Okay, so you are able to understand how complicated the entire mathematics gets in deep learning, and that is one of the reasons why it works so much better in various different things, especially in computer vision, in natural language processing. In these fields, deep learning excels more than machine learning at any particular point of time. It works so much better than machine learning at any particular point of time, because we can generate such complex architecture from it. We can generate such complex architecture from it, guys. Now there are 3 kinds of deep learning architectures that usually exist. Okay, these are called as the ANNs, the CNNs, and the RNNs. Okay, these are the 3 basic. Okay, of course there are many more architectures that are there, but we will be considering ourselves to work with just 3 of these architectures. We will not be considering them. Our main focus is going to be on ANNs itself. We will be learning about ANNs. Okay, but there are CNNs, RNNs as well. So can you guys let me know what is the full form of ANN? That you should already be able to understand, right? CNN and RNN I will be explaining right now, but what is the full form of ANN? Can you guys let me know? Okay, Sanskruti is very fast. Artificial neural network, that's right. So ANN is basically your artificial neural network. Okay, the ANN full form is artificial neural network, guys. That whatever we were seeing right now, that is called as artificial neural network. CNNs is called as convolutional neural networks, and RNNs is called as recurrent neural networks. Well, the neural network part is the absolute same, so I'm just putting commas right over here. Okay, so these are the 3 types that exist at any particular point of time. Your artificial neural networks is the most basic kind that usually works with numbers and everything, numbers, text, all this kind of basic information that is there. That is where your ANNs are being used. Okay, your CNNs are used in images and your audio. Okay, images, audio, sometimes text as well. That is where your CNNs will be used. Okay, mostly images and audio is something that we work with convolutional neural networks. Your RNN is basically time sensitive data. Okay, time based data. It's for example your videos. Okay, your trading. Okay, so you must be doing stock trading and all this kind of stuff. So your trading is also something that comes into RNNs itself. So these are made for particular kind of data where the data is a bit different from the normal data that we usually have. Okay, so for example, CNNs will be used in, for example, let's assume that you are having your phone. Okay, you have your Google Google Lens. Okay, Google Lens. You can just scan a particular text and it will convert it into just open the Google Lens, put it up on a particular image itself, and it will get it converted into your whatever language that you want it to be changed to. So that is where the image is being taken up, and then superimposed image is being put of the converted like a language, some other text itself, other language itself. So that is basically where CNNs are being used. For example, identifying whether like a picture is of a picture of a dog or a cat. Okay, dog or a cat. Okay, for example, what is that? Dog or a cat itself. Okay, so right over there you will be having CNNs being used. Similar to that, RNNs are being used. For example, what is happening in this particular video? If I want to identify what is happening in the video itself, that is where the RNNs will be used. Okay, maybe you are working on the stock exchange. Okay, you want to predict the pricing of a stock on the basis of the on the basis of the data that is there of the stock in the previous years as well. So that is where your RNNs are being used. Are you guys able to understand this examples? Okay, of course we are not going into convolutional neural networks and recurrent neural networks. We will be having a separate bootcamp for CNNs and RNNs in the future. Right now we will be dealing with ANNs or artificial neural networks itself. Okay, why these new networks are necessary? So what happened, so back in 1950s, these guys were able to create the first ANNs. Okay, these guys were able to create the very first ANNs that was basically used to in your banks. Okay, in your banks itself you are having your checks, right? You are having a check that looks something like this. Okay, the amount to be filled. Okay, it's text right over here, then your signature right over here, some of the details, all these kind of stuff. So your check is basically there. In a check, you usually write the number, right? 70164. That is basically the number that I want to pay, 70,164 rupees. Okay, so this is a handwritten thing. Okay, this is handwritten. So they wanted to be able to, so OCR, okay, basically this is called as OCR. Okay, so they basically wanted to read this handwritten digits and convert it into a digital format where it is editable. So 70164 in a digital format itself from the handwritten format. Okay, so that is where these researchers use the very first implementation. Yes, optical character recognition, Samrat, that is the full form of OCR, where you are able to recognize the handwritten characters and convert them into your digital format. That is the MNIST dataset. Okay, MNIST, MNIST dataset. That is what we will be also doing in this particular bootcamp. Okay, that is the project that we will also be working with. Okay, that is the MNIST dataset, guys. Okay, so they wanted to categorize a particular handwritten digit into 0 to 9. Okay, that was the categorization that they wanted to do right over there. Okay, so for that they created the very first set of ANNs and it worked as well. Now the problem, if you guys remember from yesterday's class, and I told you guys that at that point of time there was a biggest problem. Okay, that was MNIST is the name of the data set. Okay, the data set, don't worry about it. We will be doing the MNIST dataset itself. I'm just giving you the name right over here so that it stays in your mind that when we are starting the project, you know the brief history of the project itself. Okay, so we will be doing it. You don't have to worry about it right now. You can just focus on the story. Okay, so what happened at that point of time, if you guys remember, I told you this particular point that the fastest computer, okay, the fastest computer at that point of time was slower, okay, than the current phones that we have. Okay, are you guys able to understand this? Please do let me know. Are you guys able to understand this? Please do let me know, guys. You guys remember I told you guys the fastest computers at that point of time were slower than our mobile phones as well. Now this deep learning entire architecture that I showed you guys right now, this was one of the simplest architectures. It gets more and more complex from right over there. It requires, and all of that is basically mathematics. All of that is basic mathematics itself. Now for doing mathematics, a good processor is needed. Okay, to do so much maths, a good processor is needed. Now CPUs, for example, running a project, okay, running a project on a CPU, okay, will take you 3 to 4 hours. Okay, a good CPU. Running a project on a GPU, okay, will take you 30 to 40 minutes. Okay, and then there's something called as a TPU as well that will take you at least 10 to 20 minutes itself. Okay, so what happens right over here? What happens right over here is CPU is basically your Intel CPU and all these kind of stuff itself. Okay, CPU is something that give me a second, guys. Give me a second. You Akash, which particular group are you on right now? What WhatsApp group is there? Could you let me know? Which particular WhatsApp group have you joined? Please do let me know, guys. Akash, could you let me know which particular WhatsApp group have you joined? Python hash 20. Okay, give me a second, guys. Give me a second. I've informed my operations team to look into it as soon as possible, guys. I'm so sorry that you guys are facing this particular problem. Okay. Number 10, 18, 13, 12, 12 as well, right? I'll just tell them 7 and 12, 7, 12, 18, 13, 7, 12, 18, 13. Okay, I'm so sorry that you guys are facing this issue, guys, because we are a non-profit organization. We actually don't have a lot of people working for us. So we usually have to handle most of the things through volunteers and everything. So I'm so sorry that you guys are facing this particular issue. We'll try to make sure that we this type of problem is not happening from the future as well. Okay, so but still, related to that, usually the boot camps will happen from 7:30 itself. We will not be changing the timings. So you guys can just set up an alarm if you guys want and continue from right over there if it's possible. Okay. The Telegram channel is down in the description of the video itself. I'll make sure that whatever the case is, we will put up the particular link on time on the Telegram channel, because I know this is also very irritating for you guys. So I will try to make sure that this problem is not happening. That would be my priority. Okay, so let's continue with the class itself, guys. like I said, CPU, deep learning project running on the modern CPUs. Okay, the latest CPUs itself, a small project will take at least 3 to 4 hours to complete. A GPU will take only 30 to 40 minutes, and a TPU will take 10 to 20 minutes itself. Okay, 10 to 20 minutes. Now, what happens right over here is that CPUs cannot do parallel processing. Okay, CPUs cannot do a lot of parallel processing. You must have heard about like 6-core CPU, 2-core CPU, 12-core CPUs. So these are cores are where you are having multiple threads where parallel processing, parallel computations can happen. Okay, parallel mathematical computations can happen. Because the number of cores are so less in each of these CPUs, the threads are less, and hence in the number of parallel computations, parallel mathematical equations that they can run is very less, guys. Okay, it's very less. That is the reason why, and deep learning, like you said, there's a lot of mathematics right over there. Okay, the lot of mathematics that is there, right, guys? So it can take up to 3 to 4 hours itself. It can take up to 3 to 4 hours itself. Okay. Mac GPU takes 6 hours and CPU takes 2 minutes on VS Code. Can you explain why? Because Mac does not have a dedicated GPU. I'm talking about dedicated GPUs, guys. When I'm talking about GPUs, understand that this is a dedicated GPU. For example, RTX, okay, RTX 3060, okay, or 2070, okay, or I don't remember, 1060, I don't remember which particular GTX that is there. Okay, so these are dedicated GPUs, guys. CPUs, I'm referring to Intel CPUs, okay, I'm referring to AMD CPUs, okay, these are CPUs that I'm referring to. Now these numbers that I've told you guys right over here is something that I've taken up from Google Colab. And one more suggestion that I'll be giving you guys: never, ever, ever use MacBooks for deep learning. Okay, that is something that I've learned in a very hard way itself. Never use MacBooks for deep learning, guys. I've already lost 2 MacBooks previously. Okay, so that will be my suggestion. Okay, do not use MacBooks at any particular point of time. You use Google Colab. Colab provides you a GPU of 6 lakh rupees, okay, for free to use the Tesla GPU. Each of these GPUs cost almost 6 lakh rupees in India. So that kind of GPU is being allotted to you in Google Colab. So use Google Colab. Do not let, because what happens is your deep learning programs are very, very, very computationally intensive. Okay, very computationally intensive. When something is computationally intensive, and this is a small project. Okay, I used to create projects that were almost like took 3-4 days of continuous 24 hours that was running, cannot stop a process. It took 3-4 days of continuous running to actually get the project done. Okay, so in that particular case, the laptop gets heated up very easily. It gets burnt away. The motherboard will get fried. I've already lost 2 laptops of MacBook at some particular point of time. My suggestion would be never. So why to use your own computer's resources when somebody from Google is providing it to you for free? Okay, that is my main point. Okay, use their resources, burn their servers. Why to waste our own money? Okay, so CPUs are like Intel and AMD CPUs. GPUs are like NVIDIA RTX 3060, GTX 1060, or maybe like AMG also has this others like GPUs that it provides, graphical processing units. Now GPUs have like 3000 cores. Okay, GPUs have like 3000 cores itself. Okay, Anuj, you don't have to take a Google Colab Pro. We are using Colab for free. Okay, it provides you the GPUs as well as the TPUs for free itself. So don't pay for anything that's already for free. Okay, so GPUs have 3000 cores itself. Each of these cores have a lot of threads as well. So it is able to do much more parallel processing at any particular point of time. Now we will be using something called as TensorFlow. Okay, for our deep learning project, we'll be using TensorFlow version 2.0. Okay, that is the second latest version of TensorFlow itself for our project. Okay, so this TensorFlow itself, the concept of TensorFlow is based on something called as tensors. Okay, just like you are having vectors itself, you must have learned about vectors when you were in school. Okay, right? So something like that is a concept called as tensors as well. these are also similar to vectors itself. I'll be explaining you when we'll be starting with TensorFlow. I'll be explaining you what a tensor is. Okay, so now these tensors are like vectors that are having a matrix like body. Okay, vectors, okay, that has a matrix. Okay, just like your 3 by 3 matrix, 3 by 2 matrix, all this matrix and multiplications you have already learned in your school as well. So integrate both of them together, you get a tensor. We'll be learning about tensors in much more detail in tomorrow's class, but just try to understand this for right now. Now these tensors, okay, so Google created a particular new hardware. Okay, Google created a hardware from scratch that was able to process these tensors at a much more exponential faster manner from TPUs. Okay, much more faster manner than TPUs, guys. Okay, tensor, so these from GPUs itself. And this particular hardware that they created that was able to cater to these tensors was referred to as TPUs, or tensor processing units. Okay, TPUs or tensor processing unit, guys. Are you guys able to understand this? Please let me know. Are you guys able to understand this? Please let me know, guys. This is basically hardware, guys. Like CPUs and GPUs are something that you already know. I shouldn't be even spending any time on explaining what a CPU and a GPU is. Okay, this is something that is being taught to you guys in your first and second standard, like not even like 10th or 12th, like first and second standard knowledge of basic computers. What is a CPU and what is a GPU? Okay, TPU is something that I need you guys to understand. That is my responsibility. GPUs and CPUs is not my responsibility, guys. I understand that you guys have covered up your first and second standard logics itself. If you don't know that, then you are in deep waters, man. Okay, so like I said, these TensorFlow that we are going to use from tomorrow to actually code deep learning projects is basically built on something called as tensors. Okay, it's built on a data structure called as tensors itself. We will be understanding what a tensor is right now. Just understand that that is data. Okay, that is data, and all the computations, all the mathematics that happens on this tensor itself. So Google, who created TensorFlow, TensorFlow is a baby of Google itself. Okay, we have a particular instructor in DevTown who is currently working in like developing TensorFlow itself. So like I said, they came together to create a new hardware. Just like you're having your CPUs and your GPUs, they came together to create a new hardware that is called as a TPU, or a tensor processing unit. Now you cannot buy a TPU, you can buy a CPU, you can buy a GPU, whatever you like if you have money. But even if you have money, you cannot buy a TPU. That is something that only Google owns. But these Colab notebooks that we were using, okay, which was free, it provides you access to the best quality CPUs, the best quality GPUs, as well as the best quality TPUs as well. So you can basically change what we were currently using is just CPU, okay, but GPUs and TPUs is something that we'll be using as well. So where Python plays role, Python is the coding language that you use. Okay, so for example, Python is just a programming language, you code in that. But which particular software are you using? Okay, which particular software, which particular technology are you using? For example, you can use PyTorch for deep learning. Okay, that is again a new technology that has been developed by Facebook. Similar to that, you can use TensorFlow for doing deep learning as well. That is a technology that is made by Google. And Python is a programming language that you use to actually code that particular technology itself. Okay, is Colab and Jupyter the same? Jupyter is something that you use on your local laptops itself. It utilizes the resources, the CPU, the GPU from your own laptop. Okay, whereas Colab provides you an online platform where you don't utilize any resources of your laptop, but actually run it on the servers and the CPUs and GPUs and the TPUs of Google itself instead of yours. So even if you are running it for 12 days straight, the server of Google is going to get fried. You are not going to have to pay anything for that. Okay, so you are always safe in that particular process itself. So are you guys able to understand this TPU? Okay, so the TPU was actually built so that it is able to do calculations, do mathematics on these tensors at a very much optimized and a very much fast process when it compares to GPUs and CPUs as well, because it was built for only doing that. Okay, GPUs are also built for gaming and other things as well. CPUs are built for various different things and we are utilizing it right over here. TPUs were built only for one particular topic, that is to be able to do stuff on tensors. Okay, so tensors are not just used in deep learning, but other applications are also there, but we will be considering this for our purpose. Okay, are you guys able to understand this? Should I code on Collab or than Jupyter? Yes, my basic suggestion will be, until and unless it is absolutely necessary, there is some problem that is there, that if you're not doing it on Collab, you have to do it on your laptop itself, then only choose to do deep learning on a laptops, guys. Otherwise, always choose to do deep learning only on Collab notebooks. Keep your laptop safe. Okay, keep your laptops and your phones safe, guys. So back in 1950s, even after achieving all that, they didn't have access to these type of hardwares. Okay, these type of hardwares itself. That is the reason why they thought that their plan failed. Okay, because they were not able to train. Okay, they were not able to create deep learning models easily. So they thought that their entire idea failed, and they discontinued it for almost 70 years. Okay, almost 60 years itself. Deep learning started to gain its reputation back again in initial 2000s itself. Okay, initial 2000s itself, because of one factor, that the hardware started getting more and more advanced and more capable enough to handle deep learning models. Training deep learning models, it could handle that. So for almost 60 years, deep learning was left alone because people thought that that entire idea failed itself. But right now, everything around you, even YouTube, even your Instagram recommendations, your Siri, your Google, your Alexa, your Tesla cars, everything is based at the core on deep learning itself. Deep learning is so powerful right now, guys, that most of the time you will be able to see that most of the people will be using deep learning for their practical applications itself. Okay, are you guys able to understand this? Please let me know, guys. Are you guys able to understand this? Please let me know. Right now, I'll be sharing the attendance for today, guys. Tomorrow, we are going to start off with our practical implementation of the technical stuff in deep learning. Okay, please be ready for it, guys. We'll be starting our practical implementation of deep learning, guys, from tomorrow onwards using TensorFlow. Okay, today there is no assignment for you guys. Okay, I'm not giving any kind of assignment to you guys today, but make sure that you are able to like attend tomorrow's session on time. It will be exactly at 7:30. So even if a message is not being shared with you guys, please try to be on time for the class. Okay, that will be very helpful for you guys itself. Okay, and I'll be showing today's attendance. Right now there is going to be a question. Okay, there is going to be a question inside of this particular sheet that you have to answer. Okay, if you are not putting the right answer to that particular question, you are not going to get the attendance for today's class. You're not going to get the attendance for today's class, guys. And if I find somebody answering that particular question in the live chat, that particular person will also be not getting the attendance, guys. Okay, please do not do that. The reason for that is very simple. I want you guys, okay, I want you guys to be able to understand that if the certificate is going to everybody, you are not going to get the benefit of those certificates. Okay, you're not going to get like the benefits of these certificates itself. There's no value to these certificates at any particular point of time. I want to create value for you guys. To be able to do that, I need some help from you guys. Please do not put the answer to the question in the live chat, guys. That's the only thing that I'm asking from you guys. Okay, I'm just creating the same, guys. I'm creating the question. Give me 2 minutes, guys. I'm creating the question, guys. Give me 2 minutes. I'm not showing you the screen because I have switched it off, because I don't want to see you the question right now while I'm typing it. Okay, you guys should be able to understand this. Okay, it will be an MCQ, guys. It will be an MCQ. So I've created the question for you guys for today's thing as well. I've opened up the link, copy the link, shorten the link, copy. Now I'm going to paste the link in the live chat, guys. I'm going to paste the link in the live chat, guys. If I find somebody posting the answer in the live chat, I guarantee you that that person is not able to get the certificate. Don't tell me at a later point of time, sir, I didn't get the certificate itself. Right now it's 8:17. The sheet will be closed in just 4 minutes. Okay, the attendance sheet, let me just change the attendance sheet once again. Give me a second. I will just make the attendance sheet a bit shorter so that it's easier for everybody to use. Give me a second, guys. I will just change the attendance so that it is we don't, whatever the unnecessary things are there, we can just remove that. For example, this is not required, let's remove it. We don't require the graduation year, let's remove that as well, so that it is as small as possible. Okay, it is as small as possible, and so that you guys are able to finish up the attendance in let's delete this as well. Done. Responses. Okay, so now the attendance sheet has been created. I will be giving you guys 4 minutes to fill up the attendance. Right now it is 8:18. At 8:22 the attendance link will be closed. At 8:22 the attendance link will be closed, guys. At 8:22 the attendance link will be closed. At 8:22 the attendance link will be closed, guys. 8:22 the attendance link will be closed. At 8:22 the attendance link will be closed. You have 4 minutes. Okay, at 8:22 the attendance link will be closed, guys. At 8:22 the attendance link will be closed. So people have started filling up the attendance as well. I'm able to see people have started filling up the attendance. You have 4 minutes to fill up the attendance, guys. At 8:22 the attendance link will be closed. I'm telling you guys right over here, right now. You have 3 more minutes to fill up the attendance. You have 3 more minutes to fill up the attendance, guys. You have 3 more minutes to fill up the attendance, guys. The link is in the live chat. I've already pinned it up. There's not a lot of like rocket science for that. Okay. The question is also something that if you have attended the class yesterday, you will be able to fill it up. If you have not attended the class yesterday, you will not be able to fill it up. As simple as that. Pranay Sharma, your name has been noted. You will not be able to get the certificate. My team is currently sitting in the live chat and noting down the names of the people asking the question as well as the people who are answering the question as well. Samyak, your sheet has been gone. Okay, I'm telling you right now, you will not be able to get the certificate. So Samyak has not gotten the certificate. Okay. Pranay Sinha will not be able to get the certificate as well. You have 2 more minutes to fill up the attendance form, guys. 2 more minutes to fill up the attendance form. You have 2 more minutes to fill up the attendance form. Now you have only 1 more minute to fill up the attendance form, guys. You have only 1 more minute to fill up the attendance form. they've gone an irrelevant question. Why would Google willingly let their servers and all get damaged, and that too for free? Because they are able to use it. Okay, they don't have any usage for that. If you're not using a server, they have millions of users that are there. Okay, there are millions of users. Okay, so the attendance is gone, guys. I'm closing the attendance form right now. The attendance has been closed. Okay, the attendance has been closed for today's class, guys. So a good question that I was able to see right now from a particular person. And so Nandana Francis has asked a good question according to me. An irrelevant question. Why would Google willingly let their servers get damaged, and that too for free? So basically what happens, Nandana, try to understand this. Okay, try to understand this, that in the backend, okay, Google has to cater to one more than 3 or 4 billion people at the same point of time. Okay, Google has to handle more than 3 or 4 billion people at the same point of time. Okay, so in that particular case, it becomes very difficult. Okay, in that particular case, it becomes very difficult for them to maintain these servers if most of these servers are not in use. Okay, it becomes very difficult for them to not maintain these servers because it's very difficult. Okay, it's very difficult, okay, to maintain these servers. So you using these servers is actually a boon for them, because the servers is continually getting utilized. Okay, if you leave your PC for like 2-3 years without using it, it will not work properly. Okay, so that particular problem they are able to address from right over there. The second thing is, as many people start using Google Colab to practice data science, more and more people are able to get better at it. Okay, it becomes easier for Google to hire students as well, because if many everybody is using it, then Google will easily be able to get the cream layer from that. Okay, Google will easily be able to hire the cream layer from that itself, because everybody is the best, everybody is practicing, right? That is the case. The answer is basically, let us check what people have filled up. Okay, the answer is basically survival of a person on Titanic on the basis of gender and age. So 545 people have only given the right answer. 545 people have given the right answer, guys. Okay, so you are easily able to see how many people are not, okay, are not either coming to the classes on time, they're not listening to us on time, and these guys shouldn't be able to get the certificates as well. Because what is the point of conducting coming to classes live after my office every single day, conducting boot camps, if only 545 people are actually listening to me? So no problem. These people, congratulations, you have given the right answer. Okay, you guys have listened to me carefully. Okay, that's good. Please suggest a book for learning CSS. Never learn CSS from a book. Okay, practice as much as possible. Search for it on Google. Practice as much as possible only. Okay. There's no need to extend the Google form. Okay, 5 minutes is more than sufficient to fill up a form that has only how many, 1 2. So this is also something that gets taken up automatically. So 1 2 3 4 5, just 5 things. Okay, in that 2 buttons are there, 5 questions, 5 things that you have to type in that as well. I'm not giving you guys any QR or something to scan. You have to work off from your like a link itself. That is more than sufficient time. And as you are able to see, there were only 800-900 people live with us as well, and that is the amount of people who have filled up the attendance. So that means that was absolutely correct. There was no issues with the same as well. Okay, so we'll be continuing according to the same itself, guys. All these people, okay, all these people will be moving for tomorrow itself. I have given you guys more than 4 to 5 minutes. That is more than sufficient to put up the answer and everything. Okay, so there is no assignment for today's class. Okay, we will be meeting tomorrow and starting off with our practical projects as well. So we'll be meeting tomorrow and starting with the practical projects, and we'll continue from right over there. Okay, guys. Thank you so much, guys, and we will be continuing from right over there, guys. Thank you so much. Thank you.